Hello. In this video, we will discuss about composite testing. This is a very important aspect of composites because we need to know the how the composite behaves, either mechanically, chemically, or the physical properties of these composites. But we cannot use the same methods we apply for metals even for composites because composites are very different from metals. We need to use these test methods we are very different and which are specific to the composites. So in this video, we'll go in length about what are the different test methods one can use to apply for composites, which will be useful in arriving at different mechanical properties and as well as other properties. So when we look at testing of composites, of course, there is a series of tests ranging from physical properties such as like what is the density of the composite or what is the volume fraction of the composites. And then comes the mechanical test where we are looking at the elastic modulus or the shear modulus, Poisson ratio, and the strengths corresponding to these loads. And we may also be interested in the chemical and thermal properties such as the glass transition temperature or the melting point temperatures, as well as the water absorption capacity of these composites, or how it is influenced by different chemicals which are available in the operation environments. And lastly, also the rheological properties, which are important because most often these matrix materials are made up of polymers, where again we need to know the viscoelastic behavior using few rheological tests. But in this video, we'll focus more on the mechanical properties. Here are a series of mechanical properties which we are interested in to know about the how the composites behave. Most of it are like very basic properties such as the tensile properties, compressive properties, and the flexural properties. But we may also be interested to know what is the shear behavior of these composites. So the in-plane shear as well as the shear between two layers in a laminate. And lastly, we may also want to know what is the residual strength of these composites when they are damaged. So there are some specific tests which we will discuss for that as well. So let's start with the tensile test, which is the most basic of the tensile mechanical tests. So here is the geometry of the specimen, and this is according to ASTM standards. So in addition to this standard, there are several other standards where one can follow to test the tensile properties of a composite laminate. Here we have a rectangular specimen where the cross section again is a rectangle. As you can see here, towards the end of the specimen, we have tabs. Why are tabs used? These reduce the stress concentration at the gripping region because here is the place where we grip the specimen to load it on both sides. So to ensure that there are no stress concentrations, so that if we avoid stress concentration at the gripping area, we ensure that the failure happens at the middle of the laminate. Ideally, we want the failure to occur close to the center of the lamina or the laminate so that the properties we observe are more reliable. So that the properties we measure are more reliable. So what are the kind of properties one can get from this test? We can get the tensile modulus and the tensile strength. We can also get the Poisson ratio. How do we do this? By placing strain gauges, uh, both along the loading direction or and as well as in the perpendicular direction. So we have this epsilon 1 and epsilon 2. From that we should be able to find out what is the Poisson ratio. Next comes the compression test. Usually compression tests are much more difficult compared to the tension test, mainly because of buckling. So the moment because we know the composite panels, usually the slenderness ratios are high, meaning their dimensions are much longer compared to the thickness of the panel. So let's say if there is a panel and we are applying a compressive load, we expect it to buckle first even before it shows any compressive failure modes. So how do we avoid buckling? One way to avoid buckling is to ensure that the length of the specimen is limited. So if the height of the specimen is limited, then the buckling loads are high, so the failure will first happen in compression and then goes to the buckling. So here is one of those tests, IIT RI test, which ensures that we can find the compression properties by avoiding the buckling. But there are other methods also to find the compression test, which include the sandwich edge compression test. Here too, we are focusing on the laminate, but to find the compressive properties of the laminate, we take two of those composite laminates, and in between these two composite laminates, we add these aluminum honeycomb. So essentially, though we are interested in this laminate, we also add this honeycomb such that that avoids the buckling. And then there are these end caps as well. So what do these end caps do? First, they ensure that these are uh, tightly held, in the sense these two laminates as well as the aluminum core are held together, and it helps in applying the loads. It also ensures that there is no opening happening at the edges. So with this, we avoid the other failure mechanisms before we learn the compressive behavior of these laminates. So after this, now let's look at the flexural test. Actually, in composites, most often people go with the flexural test because these are very simple. The specimens are simple to prepare, as well as the text pictures are also more straightforward. So usually it is done using a 3-point bend specimen, where you have a composite laminate in the form of a rectangle shape, which is placed at two supports. So this is, let's say, support 1 and support 2, and then we apply the load at the center. So from this, it is almost like bending because we have two supports at the either end, and at the center you apply the load. So the way it deforms is this laminate takes a curvature, and once you know the load, we can find, and once you already know what is the deflection of this laminate, one should be able to find out what is the flexural modulus as well as the flexural strength using the basic strength of materials formulas. But in addition to the 3-point bend, there is also a 4-point bend which sometimes people use, mostly because in the 3-point bend at the center the load is focused at a single area, but in a 4-point bend now you are distributing the load at 2 points. So usually this is more applicable for ceramic composites, where you don't want to apply a concentrated load and induce failure at the point of contact. So this is one means to reduce that concentration of the load, but again it introduces this bending, from which we should be able to calculate what is the frictional modulus and strength of the laminate. Until now, we have been focusing on the tension, compression, and the flexural test, which are the in-plane properties, but the normal stresses we are looking at. Now we will look at the shear stresses applied. How do we apply shear stresses in plane? So one method is to use this plus minus 45 shear test, where we have a laminate in this form, like plus 45 minus 45, maybe we can repeat it n times and ensure that it is symmetric. So for this specific laminates, if you have two strain gauges, one finding the strain along the length of the specimen and a transverse strain gauge which measures strain in the perpendicular direction, we can use these two strain gauge values as well as the applied loads to find what is the shear stress applied and the shear strain. So these are the shear stress. So though we are applying a normal stress, one should be able to find out the shear stress because the orientation angles we have chosen are plus and minus 45. Similarly, for this specific laminate, we should be able to find what is the shear strain once we know the normal strains in the x direction and in the y direction. So from this, one should be able to find out what is the shear modulus, and if you load till failure, we will also know what is the uh, shear strength of this laminate. There are other means to do this. The other one is a shear test shown here, where there are double notches in the specimen, and along this line the loading is ensured that there is a pure shear occurring at this cross section. And if you look closely, though we are applying a load here on the specimen, it is being applied load at 4 points: 1, 2, 3, 4. So these 4 loading points ensure that there is a pure strain at this cross section between these double knots. So this is another way of finding the shear properties in this laminate. So until now we have been looking at what are the properties within the plane of the lamina or the laminate. But now we look at how good or how well the bonding is between the laminates. So since we said laminate is a sequence of lamina, so between these two lamina we bond it together again using adhesive. We want to know how good that bond is. For that we can find what is the interlaminar shear strength. Essentially we are only focused on once we apply a shear load how good that bond is. So one way to test that is to use this short beam shear test. Again this is very close to a 3-point bend test, which we use to find the flexural properties. But here once we use a short beam, the preferred failure mode is through these interlaminar shear cracks. Since we know the failure is in the interlaminar shear cracks, we should be able to relate the applied load to the resistance of shear in between these laminas. Till now we have been focusing on laminates which, let's say, are just prepared and we were testing to find the mechanical properties. But now let's focus on a damaged laminate. So for example, let's say this damage is occurring through impact. So let's say like the low velocity impact examples we look at, like a tool dropping on a composite panel or a bird striking a wind turbine blade is also an example of a low velocity impact. We said in these instances what usually happens is there is a delamination occurring within the laminate, meaning at the surface we can't see it with naked eyes, but within the laminate there are few damages. One of those is delaminations. So how can we find it? Of course we can go through the non-destructive testing methods, but there is another method where uh, we find the compression after impact, meaning we are interested in what is the residual strength of these laminate after we know that there is damage. So here is this setup where, let's say, this is the uh, laminate we are testing, and as you can see it is tightly fitting the fixture. There are grooves here. The reason we have a groove is because this panel will sit in those grooves. These grooves will ensure that while you apply a compressive load, this panel doesn't buckle, or at least the resistance to buckling is there. So essentially we are looking at what is the compression load this panel can take before failure. The reason why we do this test is if we do the test for a perfect undamaged panel versus if you again repeat the test with a damaged panel, we expect that this compression strength will be less. The reason why the compression strength is reduced is because this laminate had some internal damages, because once you have these internal damages that leads to propagation of the cracks and compromise the laminate much early. So that one should be able to find out using this compression after impact test, or in short we call it a CA8 test. So in summary, let's see what are the different tests we have looked at. We have looked at the tension test and the compression test. In the compression test we said the major problem is buckling. We need to avoid buckling before we can test the compression strength. So the test fixtures needs to be carefully looked at. Next is the flexural test, where we discussed about either the 3-point or the 4-point bend fixtures one can use to find the flexural strength and the modulus. Later we also discussed about two different fixtures one can use to find the in-plane shear test. One is the plus or minus 45-degree shear test, and the other the one with double notches and with 4 loading points, where we said at that cross section between the notches one can achieve predominantly shear stresses. And later we also discussed about how to find what is the shear resistance between two laminas which are joined in a laminate. So once we there too we have said we will use the 3-point bend test, but there we will be using a short beam where the preferred failure is the shear failure or the interlaminar shear failures. So lastly, we also focused on how do we test what is the residual strength of a damaged laminate. So in that case, we were focusing on compression after impact. Mostly we are looking at impact damages which we cannot see with the naked eye, but they are within the laminate. So one way to see what is the residual strength is to use the CAI, which is the compression after impact test. So these are only the commonly used test methods one use with the composite, but of course there are many more different methods which are more specific to the application at hand. And I need to make this very important point saying that the approach we are following here is the mechanics of the materials approach, but there is another approach called the fracture mechanics approach to analyze failures. And in that again there are several different test methods which are available to first look at what is the fracture resistance in opening mode and the fracture resistance in shear modes, as well as if there is both opening and shear modes, what are the specimens one should use. But that's a very advanced topic which we are not focusing at least in this introductory course. So in addition to this, here we have limited our studies to most the initial ones are all quasi-static loads, and the last one is a dynamic load, which is the impact load. There are other methods to apply dynamic loads, like one of it is drop tower. So where we have an impactor which is falling on the specimen. So the velocity of this impact and the mass of the impactor will tell you what is the energy at which the impact is occurring. And using these drop tower test, one can see what is the resistance of this panel for absorbing the energy or resisting damage for impact loads. Okay, thank you.